Good evening, guys. This is Mr. Holmes coming to you guys to talk to you about how to divide rational expressions. All right. When dividing rational expressions, what I want to do first is I want to go over something that you should have learned in elementary school is dividing fractions. Because a rational expression is simply two polynomials written as fractions, I want you to review this concept. All right, so something like 1 divided by 3 here, 1 over 3 divided by, say, 6 over 5. Back in elementary school, they should have taught you that when you're getting ready to divide fractions, you are to use the keep, change rule. What I mean when I say that is you're going to keep your first rational, in this case fraction, the same. 1 over 3. You're going to change your division into multiplication. So in elementary school, they used an X. Then you're going to change your second fraction. In other words, you're going to take the reciprocal. Instead of it being 6 over 5, it would now be 5 over 6. And from here, you will multiply straight across. 1 times 5 will give us 5, and 3 times 6 will give us 18. This same rule, this same principle, this same concept is used and continued when we're talking about dividing rational expressions. Okay? So keep the keep, change rule in mind when we're talking about dividing rational expressions. Here we go. A rational expression, again, is an expression where you have two polynomials written as a fraction. So what I would like to do here is I would like to go ahead and start by giving you an example. So let's do this here. We will have 7x divided by 2x minus 10 divided by x squared minus 6x divided by x squared minus 11x plus 30. Now, again, you have here at the top was simply a fraction. A fraction divided by another fraction. What is just what the numerator and denominator were both numbers. Here in high school and college, early college, you have polynomials written as fractions, and you're dividing them. All right, they be called these rational expressions. And when you divide a rational expression, you must keep the first expression exactly the same. My first fraction will remain the same. So in this case here, I will keep 7x divided by 2x minus 10. I'm going to keep that one exactly the same. What I'm going to do here, I'm going to change my division symbol now into multiplication. Because this is higher than elementary, we no longer use the x. Alright, so instead of division, instead of multiplication and putting an x, we just put a dot or a period in between the two fractions. Here we are going to now multiply by the reciprocal. So we're going to take these two and we're going to actually flip them over. So at the top now will be my denominator. Here, so I will have my x squared minus 11x plus 30. You see, my old denominator now becomes my new numerator, and my old numerator now becomes the new denominator, x squared minus 6x. Once you are here, it's now back to multiplying rational expressions, and those rules come back into play. So I'm going to just work going downward here. All right. In doing so, what I would like to do is I would like to bring down my first rational expression. 7x divided by, here, notice both of these terms in my denominator are both divisible by 2. Therefore, we can factor 2 out of this expression. So if I factor out 2, what I will be left with is, after I divide both of these by 2, is x minus 5. Again, after I factored out 2, I divided 2x by 2, and I divided 10 by 2, and that's how I got that x minus 5. Here times, here I have a trinomial. In this trinomial, the value of a is 1. Because I'm going to factor this, I'm going to now open up 2 sets of parentheses. In each set of parentheses, I'll put in an x. That represents x squared. I will now look for 2 factors of positive 30 that will also add to give me negative 11. 2 factors of positive 30 that will give me negative 11 is negative 5 and negative 6. That's how I get the binomial x minus 5 times x minus 6. I factor my trinomial. I put an x in each one of them, which represents x squared. I found 2 factors of positive 30. When I add those same 2 factors, I get negative 11, and it's negative 5 and negative 6. Here I have a binomial. In this binomial here, notice I have an x that is a common factor for them both. So I'm going to factor out an x. When I factor out an x, I'm going to put what remains. In this case, here I have x minus 6. Now what I want you to notice are common factors. Before I begin to multiply, I notice opposite numerators and denominators have common factors. Whenever you see in the numerator and in the denominator common factors, we can divide those factors evenly. What I mean is, here x minus 6 divides x minus 6 both one time. X minus 5 and x minus 5, numerator, denominator, they will divide evenly. Here I have one x here. Here I also have an x. Numerator and denominator, they also will divide evenly. What did not divide evenly will remain as part of your final answer. In this case, my final answer will be, part of my final answer will be 7 over 2. 7 is the only item remaining in my numerator. 2 is the only item remaining in my denominator. Now, we must take everything that we divided evenly, set it equal to 0, and it will determine what cannot be equal to 0. Okay? Let me say that again. Each one of these items that we divided evenly, we must now set them equal to 0 and solve. If we was to set x minus 5 equal to 0, you will quickly learn that x cannot equal a positive 5. Because if x was positive 5, it would make this 0, and my denominator would be 0, which is impossible. If I take this x and set it equal to 0, then it'll be just that. It'll let us know x cannot equal 0. And lastly, this one here, x minus 6, you set that equal to 0, and you find out that x cannot equal to a positive 6. Positive 6 minus 6 will make that 0, and it will also make my entire denominator 0. So both 7/2 and what x cannot be equal to is my final answer. Guys, this has been Mr. Holmes explaining how to divide rational expressions. And if you know Mr. Holmes, you'll know what I say. I hope you enjoyed this video and have a blessed day.